So I'm going to solve the two problems that I have had assigned as special problems. Let's do number 17. This is from 2.1. And that asks to find lambda such that the determinant of the following matrix is 0. And that is lambda minus 1, 0, 2, lambda plus 1. You might say, what is this lambda? This is something we're going to do later. And this is a letter that we're going to use. It's a Greek letter lambda, so you have to get used to it a little bit. Okay, so this, of course, is just a 2 by 2 matrix, which I remind you of the formula. If you have A, B, C, D, then this is just the product of the diagonal elements, and then just subtract from that the product of the off-diagonal elements. So in this case, that is lambda minus 1 times lambda plus 1. Don't forget with parentheses, because we're multiplying things here. That's this product, and then this product, of course, is 0, so there's nothing to subtract. And this has to be equal to 0, so that's the question for which lambda. There's no need to expand here, because we want to factor if we want to see when things are 0, and this, of course, means that lambda is 1 or lambda is minus 1. Now, this perhaps was a bit easier question. Let me do a similar one, number 18. Was not assigned, but you just do it now, because it's a 3 by 3. So lambda minus 4, 4, 0, minus 1, lambda, 0, 0, 0, lambda minus 5. And when we have dealing with determinants that are larger than just 2 by 2, we try to find good columns or rows. And by inspection, you see there's two choices. You can either choose this row or this column, because of that many zeros being there. Let me just choose the row. So I'm going to do this here. This is row 3. In the row 3, I only have to have one contribution, that is this element. That will be the factor, so lambda minus 5. And then I have the cofactor, which obtained by deleting row and column. And what's left is lambda minus 4, 4, minus 1, and lambda. Now there is also a sign, right? Remember this? And you can do the pattern, but you can also work it out like on the thing itself. So plus, minus, plus, minus, plus. No matter how you go, you have to alternate and you get the sign it is. So this is a plus sign. Okay, this would of course be even more important if there would be more terms, but no. Okay, so we have to now only calculate this determinant, but that's by the formula here. All right, so we have lambda minus 5, and then what else is there? We have this product, that is lambda times lambda minus 4, and then we have to subtract this product minus 4. To find remember the question is when is this 0? So to do this, we're going to factor this further, and we need therefore to expand this. So that is lambda squared minus 4 lambda minus plus 4. Sorry, I forgot the parentheses, otherwise this would not be correct. All right, so we now need to factor this as what two numbers multiply to 4 and add up to negative 2. Minus 2 and minus 2. Perhaps some of you recognize this actually is a double product, the double product formula. And so it actually is lambda minus 2 twice. So putting this equal to 0, either this is 0, lambda is 5, or this is 0, lambda is 2, or this is 0, but of course that gives you the exact same thing. So here the solutions are lambda is 5 and lambda is 2. Okay? And other problems like that. As I said, this is something that we're going to need later. Not the moment might be, why are we doing this? But there is a reason that we do this. Okay, the next problem that I had assigned was number 21. As a special problem, and number 21 asks you to calculate the determinant of a matrix using whatever row or column you feel like doing. And since we have again a good choice, let's take that choice. In this case there's only one, that is this column. So we do this expansion along column 2. This means that we have a single factor, 5 here, and then we have a cofactor that's obtained by deleting these two rows, between the row and the column, and we get -3, 7, -1, 5. Again, we could ask about what is the sign here, because remember there's always a sign involved, but again this is in this case a plus sign. Just walk whatever way you walk to this, by alternating you get always the same sign. Or you can just use the pattern of a 3 by 3 matrix, and you see we're dealing with this, that's a plus sign. So a plus, I write it here just for emphasis. Okay, now of course there's something still to calculate here, that's 5. Product is 15, this product is -7, don't forget we subtract, so it is 5 times 15 plus 7, that's 22, which is 110, I guess. I don't care too much about the actual value here. Okay, again, there might be problems later that we want to get determinants more complicated, but in the lecture today we will see a method that allows us to do this much quicker, and so I'm not going to do any more problems now on determinants.